presenting the paper. It's in fact not a paper, yeah. So this presentation was already presented on the Peter Nijkamp session or before ERSA Congress on the Carrefour meeting, like brainstorm. Why am I using that presentation? In fact, I was not doing any research on mobility during the COVID, yeah, because I'm a method girl, so I have no data during the COVID to present. But in fact, I was doing the research before the COVID, and then Peter Nijkamp provoked me to think what can happen. And I would say that is kind of inspiration and putting some hypotheses for further research when the data will be available after the pandemics. So as Thomas asked me to have only 5 slides, yeah, so this is the first one. I gave quite not traditionally some points to see what's there. So in fact, I will be talking quickly about natural spatial urban patterns. And the word natural is not very common in the rest of the words. It is because I'm studying the Benford law for spatial dimension, and this is very uncommon. So this is the first. So in fact, I want to just to discuss, to think, like to do the mental exercise about the agglomeration, concentration, and density in the cities, within the city. And the effects of the COVID on the business location and population location, just to ask the question if the so-called old order is something before the pandemics, if that can be really changed, yeah? So if there is somehow like a spatial equilibrium, yeah, which is also not in the literature well developed, the equilibrium of spatial relations. So the question is how we can measure that and what we can tell about those effects. Okay, yeah, so again, very synthetic slide made of 3 other from the original presentation. So in fact, from my perspective, I would say that if we are considering the business location and population location, we have to consider the real estate. So in fact, they exist, yeah? So nobody's moving the house or taking the house with them just to suburbs. Building the new real estate is simply costly. So that's why there should be somehow reusage of the real estate which exists, yeah, both for population and both for business. So just thinking about what can happen, yeah, and how the people behave, yeah. I would say that the population may see some frictions on the housing market, so in the city and outside. So some of the people who are bored with living in a city, yeah, because of the crowd, of the pollution, of whatever, and trends going green, and because of this teleworking, and so also lowering the cost of living, they will be somehow tending to go to the suburbs. Or surrounding areas, yeah, but of course they have to occupy some locations, yeah, some buildings. Of course, some of them will build something new, but majority will choose something which exists. And in fact, there's the opposite dream. Yeah? So many people who live in the suburbs, sometimes they simply couldn't afford going to the city, yeah? Because the cities were quite expensive, especially the metropolitan areas, because there are many flats which were occupied by students and so on. So the market is not, in many cities, the market of the real estate in the cities, not for big families, but also only for students or for like Airbnb for travelers. So in fact, if those locations are somehow free, yeah, because there are no students, no tourists, they can afford simply moving to the city, yeah? So just following their dreams, yeah? I would say, yeah, that can be a way. So of course it requires the high quality social transportation and internet infrastructure, especially in peripheral locations, but that makes the frictions on the market. Yes, some of them are moving in, some of them moving out, and simply they are using the existing locations. So in fact, I would say, and this is to verify, yeah, so this is the good question, that the change in the population structure will appear simply, yeah, so not fully in the population itself, but population structure, maybe in terms of education, age, I don't know whether gender, but still, for me, that will be something which happens. And the business still, just taking any theory which you have about the business location. Yeah? So business usually looks for money. Yeah? So value for money, good location, and close to people. Yeah? If you take evolutionary economic geography, they say, okay, this is prestigious to be next to embassy or to the whatever. Yeah? So to any nice place. Yes? And if they need less space, yeah, because people are online, so they can afford for the same money better location. Yeah? So I wouldn't suggest or expect that business will just move outside, building a new offices just outside. Yeah? Probably they will move into the city to use the existing resources for cheaper money. Yeah? So they will be closer to people in good location. Probably they save budgets, or for the same budget they will have something better. So the only thing that might happen, yeah, that there will be some abandoned locations, yeah, like all industries which were abandoned. But I would suggest that people still will be using the existing locations and the best existing locations. So this is something which inside of the city may happen, and we should track for that. Yeah, but that's why I'm saying I need like few years just to have the data really after the COVID, yeah, like 5 years after the COVID, to really evaluate that hypothesis. And the second thing, which is not connected to the previous slide, but this is like a global order, old order. So the previous one was local order, and I was doing the research on something which is extremely innovative. So because my husband was doing something on Benford law. I don't know whether you know Benford law. It is the law which is like 120 years old, more or less. And it was empirically derived that some numbers, if you take the long number, which has many digits, so there is a rule, what will be the first number of that number, so first digit. Yeah? And the one appears many times more often than number 9. Yeah? So mostly the numbers will start with 1 something, blah, 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 and the long numbers which start with 9 will be, I don't know, like 7 times less frequent than those which start with number 1. So there's even, if you have a computer, you can go to Google the Benford Online or something like that. There's a collection of the papers which were published on Benford law. It's like 2,000 papers at least. So mostly they are used for verifying whether there is a natural pattern. So that part is called natural pattern. And I would say that the 30% of those papers is on fraud. So the accountants, if they are looking for frauds in accounting in bills, they are using that law. So many of fiscal authorities and tax authorities in many countries do apply that checking in the back office. So in fact, if you are a business and you will be just selected for the control, in fact, that may appear from application of the Benford law that something is wrong with your bills simply. Yeah? So that's something which exists. Yeah? So it's not very common in other disciplines. So right now it's in accounting mostly. So, and my husband, he's also the professor of economics. We are walking long walks, and he asked me, okay, and Benford in space, does it exist? I said, no, come on, nobody did it. I said, okay, let's do that. So, yeah, and what we could do, yeah, so first of all, if you will take the locations, yeah, the geographical locations, it will be not working, yeah, simply, yes, because they are not, yeah, they are equally distributed, of course, except for the seaside locations, yeah, so the latitude, longitude on the sea are not taken, and the rest is quite similar. So we thought that the distance between the points could follow that pattern. And why that approach? Yeah? So in Nature, there was published a paper on the proximities to stars. So in astronomy, people are checking the systems, so this natural system, just with the Benford law. So it's really a serious research. Yeah? On that basis, they can detect whether the measurement is fine and so on. So this is called natural law. What we did, we took the Gazetteer data set. It's available in R. I'm the R girl, so I'm a lazy girl, so I thought, okay, that's no work in data collection. So in fact, there is like 47,000 locations of the cities with the population. And it is 2006. Okay, it was 15 years ago, but still, yeah, in the global history of the urbanization, this 15 years doesn't matter. And what we did, within the countries, which of course changed their borders for many times since long, yeah, we took all the locations of the cities and their population and checked and we've calculated something like a three-dimensional distance. This is like a socio-geographical distance. You have the equation over there. In fact, this is a Euclidean distance. It means that you take the differences between 2 points in each dimension, yeah? So in X, in Y, so longitude, latitude, and in population. So that is something which is to express how far the cities are in terms of kilometers and of the potential of population. So this follows somehow like a gravity model, yeah? So this is more or less the same concept. And in fact, within the countries, so only within the existing borders, we've tested that law. So with 47,000 locations, it is big majority of global cities, yeah? So if you ask me if that's a lot, there are some statistics from the World Bank and so on. So the real big cities are around like 3,000. Yeah. So when you have like 10 times more, you have really majority of the cities. And we've tested if the distances within the countries follow this natural pattern. And yeah, the map over shows what happens. So the red one is on. Following that pattern, yeah. So the red one means okay, this distance is natural, yeah, and going down, yeah, you have less and less natural or not conforming with the Benford law. So in fact, this is tested. So this well-established measure in statistics, the MET, which is testing the expected values and observed values of the again the numbers, the first number of the first digit of the number. So quite amazing. That not very common study. And I have the paper which is right now, to be corrected, just to be submitted once again to the journal which is interested in that. And in fact, I was just trying to see that in the time span of 500 years, yeah. So to explain in which country the pattern works or not, doesn't work, compared or analyzing the history of settlement. And in fact, it can be explainable. So there are some historical patterns, especially the Europe follows that pattern, yeah, because Europe was mostly using the horses to move between the cities, yeah, and the horses can go like 25-30 kilometers a day, yeah, and after that they need a rest. So in fact, the cities were built or established like those distances that people could move within one day, not to be in the middle of the night in the forest, yeah, just be in the city. And of course, for different continents, there are different explanations. Yeah, how the things were coming. So from America, the establishment of the different locations is also different. In South America, again, there are absolutely different motivations to relocate the cities or to abandon the cities, and so on, so on. So that showed that, in fact, just to conclude, yeah, if we take like 500 years of the thinking about places, majority of them, because it is like 90 countries out of 169, conforms with Benford law. So this kind of natural pattern. So if 500 years did not affect the location of the people, I don't suppose that the pandemics, which is like 3 years, could do that, yeah. So this is my doubt that if we observe that very long-term pattern, it will not change quickly. But in fact, to be honest, nobody did the research before. So in Benford Online, on this website, there's no paper on space, yeah. So nobody was using before me the Benford over the space, yeah. And I wouldn't also do that if not my husband and the walk. So and the last thing is on the local order, on the equilibrium, local equilibrium. Again, this is something, so you see those two figures. So these are the entropies for tessellated point pattern. So you take the point pattern, you tessellate, which means that you put a line in between, and then you get like areas, like polygons, which are separating the points into continuous spaces. And then you calculate on those fields the entropy. So the entropy as normal way. So again, that part is developed in the book, which was already mentioned, the one on the complexity by Aura Reggiani, Daniel Chamański, Laurie Schindler, and Roberto Patuelli. That comes soon, I suppose. So I've been testing Warsaw. I had the data for Warsaw for business locations and for population location in point. And what is amazing, this is the measure of agglomeration. It was derived like 40 years ago in 1979. I tried to develop that measure, so it works really nice. And what is quite nice, so even if the distribution over the space in the city is somehow different, but the agglomeration degree is very, very similar. So it means that I was also doing the analysis for two other cities, and the result was the same. So in fact, this level of relative entropy, like 0.84 or 85, is something which is quite stable in three cities in Poland. So why not to repeat that analysis for the cities we've analyzed today? So that can be compared. The population data are taken from the grid data, 2011, and they were like sampled within the grids of 1 kilometer to 1 kilometer. So they are extremely precise. So in fact, there is something like a spatial equilibrium, which is close to my hypothesis that the real estate is being used. People want to be in the city, and business wants to be close to the people, and people are close to business, in fact. So, of course, you can verify that with all the theories of business location and real estate location coming from Alonso and so on. So that is a long story, but on one slide there was no more place. So, to conclude, in fact, from global perspective, the allocation of people among the cities looks quite unstable. So, because it didn't change for 500 years, it will not change probably after the pandemics. From the local perspective, we have something like a spatial equilibrium for business and people. As I say, that should be tested. This is very, very pilot research just on 3 cities in Poland, but nobody also was doing that before. So if that goes, because again, the agglomeration follows the urban design, if we have the square, the old market, the old town, the railway, the airport, so you cannot change those things, so they are like the legacy of hundreds of years. So again, they are very, very stable. So in fact, I would say that having those all, I would say that the potential is very low to that there will be a really huge change. So I hope you like that. I have the details of the things in those 2 papers on natural spatial pattern and the entropy as a measure of agglomeration. So that opens something very new to regional science, I would say. So this is it. Thank you.